Hello everyone, welcome back to my channel. My name is Aseem. Today I'm going to show you how we can use the Bayesian ridge regressor model and how we can use that to try to predict the stock prices. So I've already imported all the libraries. Basically this is the NumPy and the pandas, and I've imported the sklearn also. So first thing is, let's get the data. So I have already uploaded the data in a CSV file. So let me just read that data. This is nifty data actually, on a daily time frame, and it's based on we also have the previous closing prices here. So actually I'll just show you how that looks like. Let's df.index, let's make the index also. Okay, so I'll just show you how the data looks like now. One second, what is the issue? pd.rate csv df index is df index. Oh, this is minute. Right, should work out now. Yeah, so we have the daily time frame, we have nifty, we have the OHLC, and we have the previous close. So we'll be using this data. So let's now define the what is going to be our features and what is going to be the target. So I want the feature to be, let's say, the open price and the previous close, and we're trying to use these two data points to predict the target, which is the closing price. Let's also split the data. So I'm going to split it into testing and training now. So x is equal to df, and this is our x, which is features, and the y is the target. So we have split the data into x and y, and let's make x train comma x test comma y train comma y test, and we are using the train test split function, and we'll put in x and y, and we'll put the test size, which we can probably put at 0.3, and I'm going to save the state, the random state, so that I keep getting the same results in the future also. I'm going to make my model now. So my model is the Bayesian ridge. And then I'll be fitting my model. So model.fit, and I'll be using the X train and Y train. So basically all the training data, we are using that to create our model. And let's try to predict the results now. So the model is going to predict using the X test. So we've been able to do that also. So let's see how the model actually performs. So let's evaluate the results on, let's say, the testing data first. Let's see if the test data got good results. So I'm finding out the R2 score between the Y. So before actually putting it before on the test data, let's actually do it on a trained data. I think that will be easier. Let's see if the results were good on the training data first, then I'll show it to you on the test data. So for that, I'll be needing a predict, which is model.predict, and I'm going to predict it for the training data now. So my R2 score will be the Y train, which is the actual data that I've used toward training, the Y part, the target, and the predict, right? So this becomes my R2. Similarly, my mean square error, MSE, is mean squared error, and again the Y train comma predict, and let's put our MAE also, which is the mean absolute error, which is again Y train and predict. So let's print it out. So my R2 is coming out to be this, my MAC is MAC, and my MAE is MAE. Let's see the results, how they perform. And actually the results are not that great. Why? Because if you see the MAE, the mean absolute error, that's 79 points. That means on average the model is performing actually pretty bad, because the average difference between the actual closing price and the predicted closing price is about 79 points, and this is on the training data set. So let's check it on the test data set also. So I would not require this now. So I will be using all the test data now. Just changing this to test, and this will change to YPRED, because we have already predicted the Y. Let's see the results. But one thing is different here. As you can see here, the MAE on the training data was actually poorer than the testing data set. That means if we can somehow create better model, I think Bayesian Rich can actually work out, right? So let's actually see the graph also. I think that will give us a good idea. So training, I'm using the training data as df.index, and it's all the data points before 01/01/2021, and my test is equal to df.log, and it has all the data points after this date, so 31/12/2020. And now let's try to create a test. Let's say OHL, which is test of features, and again I'm just updating the YPRED equal to model.predict, and I'm going to add the test underscore OHL. Okay, so that should give me the YPRED now. Let's plot it now. So I'm going to plot the results. So plt.rc params, let's make it 2010. plt.plot, let me first plot the test index comma test of target, and let's make it color equal to red. This is the actual data. Let me actually write that also. This is the actual data, and I'll also be plotting the predicted data now. Let's do it in a blue color, and the test target will be YPRED in this case, and I think that should give us the result. So plt.title is NACI close price, and plt.legend, and plt.show. So let's see how it looks like. And as you can see, the results are not that far, but still not extremely good also. You can see the actual ones are in red, the predicted value is in blue. It's not giving really good results, and as we can see here, the reason is this MAE. So how to make it better? Let's try to add more data points. So if we can add, let's say, high and the low also. So I've added the high and the low. Okay, it should be HIGH, and let me try to run it again. So just remember how much was the initial MAE, which was about 79. So it's got reduced to 30. So more data points is giving us better results. This is again 29. So I'm guessing the results will look much better now. So yeah, the results are looking definitely much better, and we are down to only 29 points of the mean absolute error, but still I would like this to be even further down. So we'll probably need to use some more data points, maybe volumes, to get a better result. But I hope you understand how the Bayesian Ridge model works. So I hope this was helpful, and I'll see you in the next video. Thank you.